In this video, what we're going to do is we're going to go over how to use the normal model, those z-scores that I told you how to calculate, and then also the usefulness of the 6895-99.7 rule. Remember that with any z-score, what you need to calculate it is a mean and a standard deviation of a variable. So here what we have is IQ tests, and the IQ test is developed in a specific way so that the mean is always 100 and the standard deviation is 15. Usually these come from your data set, but because we know that an IQ test is developed this way, we can just use this average and the standard deviation. So write this mean and standard deviation down so that we can use it later when we're calculating z-scores. So the IQ test was developed to try to measure intelligence or lack thereof. These categorizations are developed by someone in the early 1900s. I didn't develop them. You can look up their definitions here. But you can get a general sense of what different values mean. So anyone over 140 is a genius or near genius. And what we want to look at is if we observe someone with a specific IQ, let's say 130 or 100, how unusual is that person? Or what percent of the population would have an IQ of 130 or greater? So those are the kind of questions that we can ask. But to answer them, what we need is to look at is the normal model. So remember, the normal model follows this bell-shaped curve. And what we said with our 68, 95, 99.7 rule is that between one standard deviation, 68% of people should fall between these two IQs. Between two standard deviations, 95% of people should fall. And then between -3 and +3 standard deviations, 99.7% of people should fall. So that's how the rule is used. So you may be asking yourself, how did I come up with these numbers on the bottom? Well, the mean is 100, so the mean always falls at the middle part in a symmetric bell curve. So we put 100 in the center, and then we reach down one standard deviation, which is exactly 15, so we subtracted 15 off. And then again, we subtracted 15 from 85, so we subtracted 2 standard deviations to get 70, and then again for 55, we subtracted 3 standard deviations, so 15 3 times to get 55. The same thing is true to get the numbers above. We've added 15 to each of these. So to get 145, we've added the standard deviation 3 times to 100. So every IQ score is going to have a z-score, a unique z-score associated with it. So an IQ of 130 is going to have specifically a z-score of 2. An IQ of 145 is going to specifically have a z-score of 3. And this is going to help us then to answer questions. The last thing I want to briefly mention before we move on is that this bell curve has a specific shape such that the area underneath it is exactly 100%. So we would have to reach down to -infinity and up to +infinity to get 100%, but the area underneath this is exactly 100% of the observations. So we can use that principle and the fact that this bell curve is symmetric to start to answer questions. So let's say we observed someone with an IQ of 100, and we want to know, well, what percent of people have an IQ of 100 or something greater? To answer that question, we can't use our 68, 95, 99.7 rule because 100 doesn't fall at a z-score of 1, 2, or 3. But we can use the concept of symmetry. So this bell curve is exactly 100%, but we only want to look at the top half. So that means half of the people have an IQ of 100 or above. And so the answer to this question is 50%. Area E, F, G, H, adding those areas together is going to give us exactly 50%. That was an easy problem. Let's try something a little bit harder that uses our 68, 95, 99.7 rule. So here in this question, we want to know what percent of people have an IQ lower than 85. So 85 is associated with a z-score of -1, and that's going to be useful for us because we know that 68% of the population has to fall within one standard deviation. But this question asks for everything that's below 85%. So we're actually looking for the area A plus B plus C. Now, going between one standard deviation is just area D and E, and that's 68% of the population, which is what we said. So 100% of the population falls under the areas A through H. That's everyone. And so we can subtract out D and E to get A, B, C, F, G, and H. That's going to give us both sides below one standard deviation here and above one standard deviation here. And then we can divide by 2 using that principle of symmetry just to look at the lower half. So again, we've subtracted out area D and E from the total population, and then we've divided by 2 just to find that lower tail. So you can use the principle of symmetry to find a lower tail or an upper tail, but we can also use it to find middle portions. So in this problem, we're looking at the percent of people who have an IQ between 85 and 130. So that's going to be areas D, E, and F. So again, our area that we're looking at isn't perfectly symmetric, and so we're going to use the idea of symmetry to find that area F. So as we mentioned before, area D and E is exactly 68% because that's one standard deviation below and above. And area F is within 2 standard deviations. So if we reach out 2 standard deviations, we'll capture 95% of the data. But we want to subtract out that middle portion. So we want to subtract out D and E and just focus on F. So we'll divide that then by 2 to be left with just F and remove the C. Adding those values together, we'll get the area of area D, E, and F, which is 81.5%. So 81.5% of people have an IQ between 85 and 130. Okay, I'm going to do 2 more problems really quickly so you guys can really see how this principle of symmetry works to find tails. So here we want to know what percent of people should have an IQ above 145. So this is in this upper tail, and this is just capturing that area H that goes from 3 to positive infinity. So again, let's start with the area underneath the whole curve. So the area underneath the whole curve is 100% of the people. We want to find just people above 3 standard deviations and below 3 standard deviations. And that's going to be everybody outside of 3 standard deviations. So 99% of the people fall within 3 standard deviations. So outside of 3 standard deviations is going to be what's left, which is areas A and H. So this is greater than 3 standard deviations and less than 3 standard deviations. That's going to be only 0.3% of the population falls below 3 standard deviations or above 3 standard deviations. And then to just find the upper area, we can use the principle of symmetry to find area H. So if 0.3% of the people fall in area A or H, we just divide by 2 to find exactly area H. For this last question then, I'm going to look at what percent of people should have an IQ score below 130. Now the percent here we know is greater than 50% because we're looking at area A, B, C, D, E, and F. And anything that's above 100, when you're looking at the area below it, is going to be greater than 50%. Now, there are multiple ways to solve a problem like this. I'm just going to show you one method. If your method still comes up with the correct answer, then you should stick with your method. What I'm going to do first is try to find the area between 2 standard deviations because 130 is exactly 2 standard deviations away. So the area within 2 standard deviations is area C, D, E, and F. And we know that's 95% of the data, or the percent of people fall within 2 standard deviations. So that's part of the area that we want. But we also know that people below 70 also have an IQ below 130. And so we want to include area A and B into consideration. And so area A and B we can find by subtracting out 95 from 100. That will give us this lower tail and this upper tail, so everything outside of 2 standard deviations. And then we'll divide by 2 just to focus on area A and B. So once we have area A and B, we can add that to C, D, and F. That's going to give us 97.5, and that's the percent of people who have an IQ below 130. So that's how you use the 68-95-99.7 rule. But you may be asking yourself, what if my z-score doesn't fall in one of those exact numbers? So what if the z-score is 1.5 and it's not exactly 1, 2, 3, or -1, 2, and 3? Well, for those, you're going to have to use a z-table or a z-calculator, because the 68-95-99.7 rule only works when you have an exact integer like 0 or -1 or -2. What we'll do in the next set of videos is we'll look at how to use those z-tables in more detail, and then how we can apply the normal model to even more questions.